G'day guys. Okay, so no sound system video this time around, but I will have one coming up soon. Some of you may know I make signs for a living, and I've been asked a few times to do a video showing how to make illuminated 3D acrylic letters. So here we go. I'll start by cutting a 3mm thick sheet of translucent white or opal acrylic to the basic dimensions of the face of the letter, or in this case letters. I'll then mark out the shape on the front and the back of the acrylic. It's a lot easier to do this with square letters when you're first starting out. If you want to do round or curved letters like an O or an S or a C for example, I'd suggest using a font with square shapes. If I get enough interest in this, I may do another video on how to make curved letters later on. In my day job, I would cut all of this out on a CNC router, but I understand most people don't have access to that sort of equipment, so I'm cutting these letters out on my table saw. You could use a bandsaw or a jigsaw or a scroll saw or anything that you have access to. I actually use my scroll saw to finish off the inside cuts. I then cut out some 80mm wide strips of acrylic, and these will make up the sides of the letters. Generally I use a 10mm PVC sheet as a backplate. You can pick it up from hardware stores or plastic suppliers, or you could try your local sign shop. Alternatively, you could use MDF, which is a bit heavier and less weather resistant outdoors, but it may be a bit easier for some people to get. I traced the face shape onto the PVC and then used an offcut of acrylic to draw a 3mm inline. The idea is to make the backplate smaller than the face so that the finished letter will fit neatly over it. You can see why a bit later in the video. I cut the backplate off camera using the same technique as the face. The next thing to do is to cut the side strips to the lengths required. I use this alpha laminate cutter to scribe and snap the acrylic, but you could just as easily use any sort of scribing tool or even a miter saw if you wish to cut it that way. When doing angle joints, I found the easiest way to shape them is to eyeball the angle and mark it on the acrylic, and then use some sandpaper double-sided tape to a piece of aluminium, or you could use a block of wood, and to sand it down to the required miter. Once you've cut all your side strips to length and shaped the angles, it's time to tape them all together around the outside of the backplate. It's important for the fit to be tight, so you may need to make some minor adjustments before you start to glue it together. When you have the sides in place, you can tape the face on. I just use painter's masking tape for this. Now the adhesive that most professionals use in this job is this side grip number 3 solvent cement. You can apply it using a squeeze bottle like this with a needle tip. Alternatively, you could use a thicker adhesive like the number 16, which has a longer shelf life, but it can be a bit messier to work with. The main advantage of using a thin solvent cement is you just apply it to the outside of the joint and it kind of sucks itself in between the two surfaces, effectively welding them together. I start by applying a small amount to the outside of the joints to hold the structure together. I then remove the face before moving on to the inside. You can then apply a lot more adhesive to the inside to really make sure the structure is set in place. Another positive of using number 3 cement is that it cures almost instantly, so there's hardly any wait time before you can move on to the next step, which in this case is fixing the face to the side walls. And that's it as far as the main structure goes. You can see now how the backplate fits inside the acrylic shape. Right, so onto the LEDs. This is a smart LED kit that I purchased off eBay. It comes as a 5-meter strip, a power supply, remote control and the main control box, along with a couple of connector cables. I measured each straight section of the letters and cut the strip to length before removing the silicone cover. The cover is really only required if you're using the LEDs in an outdoor environment. The next thing to do is to join the sections together. You have two options here. You could solder the wires between each contact point, but it's extremely fiddly. And if you're not careful, you can risk creating a short between two contacts. Instead, I would recommend purchasing these pre-made quick connect cables. They snap together and are a whole lot easier to use. If you do go this way, just make sure you get the correct size, unlike I did. I wouldn't recommend trimming the LED strip to fit, but for the sake of this video it was my only option. You can see here how much easier it is to use than solder. Before mounting the LEDs, it's a really good idea to give them a test run, just to make sure all the wiring is connected properly and the LEDs are working. Before fitting together, I cut a notch in the back panel for the cable to run through and then painted some screws. This is not completely necessary, but it does add to the finish. Now normally it's a lot safer to drill acrylic with one of these step bits, but unfortunately I left my smaller version at work, so instead I'll risk cracking the acrylic with a regular twist drill. It's also a good idea to countersink the holes. And after all that's done, it's time to move on to attaching the LEDs to the backplate. For this job I've just used hot glue, but for a commercial job I would use mechanical fixings or a polyurethane adhesive. It pays to only fix the connectors in place, that way it's easy to swap out sections of LED strip if they fail. It's also important to mount any other objects like cables down to the backplate to prevent shadows in the finished product. As you can see, flat bottom letters like these will easily freestand on a bench or a shelf, but you can also mount them to a wall. Here I'm using nylon tap-ins, but how you mount it is entirely up to you. The face can then be screwed in place and that's it, job done. As I said previously, the lighting I've used is known as smart LEDs, but it can also be known as magic LEDs. This means they're programmable and have a far bigger range of effects and colours than regular LED strips. This particular kit has about 130 different program modes, and it would take me a long time to go through them all. Ultimately, I think the whole thing looks pretty cool, and I'm sure if you give it a go, you'll find it's actually a lot easier than it looks. Let me know in the comments below what you think, or if you have any questions. Now I hope you liked this video, and for those of you wanting to see another sound system build, I have one in the pipeline. Hopefully I'll get a chance to put that up soon, and thanks again for watching.